Welcome back to my YouTube channel. Myself, I'm Lokita GS. I'm studying in Department of Artificial Intelligence, which is a core branch of CSC AI. Today's subject which we are going to discuss is on theory of computation. The subject code is BCS 503. I'm studying in 5th sem. Today's topic is closure properties of context-free language. Introduction to context-free languages. Context-free languages are a class of formal languages generated by context-free grammars. They are used to define the syntax of programming languages and data formats. The study of their closure properties is essential for understanding their computational capabilities. Definition of closure properties. Closure properties refers to the ability of a language class to remain within the same closure under certain operations. For FLS, these operations include union, concatenation, and intersection. Understanding these properties helps in analyzing the limits of CFLs and computation. Union of context-free language. The union of two context-free language is also a context-free language. This is proven by constructing a new grammar that combines the grammar of the original languages. For example, if L1 and L2 are CFS, then L1 union L2 is also a CFL. Concatenation of context-free language. The concatenation of two context-free language is also a context-free language. This can be achieved by creating a grammar that generates string from both languages in sequence. Thus, if L1 and L2 are CFLs, then L1.L2, which is known as concatenation, is also known as CFL. Clean stars of context-free language. The clean star operation on a context-free language yields another context-free language. This means that if L is a CFL, then L. Intersection with regular languages. The intersection of context-free language and a regular language is a context-free language. This is because regular language can be represented using finite automata which can be combined with pushdown automata. Therefore, if L is CFL and R is a regular language, then L intersection R is also a CFL. Intersection of two context-free languages. The intersection of two context-free language is not necessarily a context-free language. This highlights a limitations of CFLs in terms of closure property. For example, the language a to the power n, b to the power n, c to the power m bar n, comma m greater than or equal to 0 and a to the power m, a to the power n, a to the power n, its intersection in a way that is non-CFL. Complement of context-free language. The complement of a context-free language is not a guarantee to a context-free language. This means that if L is an CFL, then its complement may be CFL. Real property emphasizes the limitation of CFLs in computational theory. Closure under homomorphism. Context-free languages are closed under homomorphism. This means that if L is CFL and H is homomorphism, then H of L is also a CFL. Homomorphisms map symbols from one alphabet to another, preserving the structure of the language. Closure under inverse homomorphism. Context-free languages are also known as closed under inverse homomorphism. Given a morphism H and a context-free language L, the inverse image L of H of 1 minus 1 L belongs to CFL. This allows for transformation that can still generate context-free structures. Context-free languages and substitutions. Context-free languages are closed under substitution. If L is CFL and each symbol in L can be replaced by a context-free language, the result is still a CFL. This property allows for the creation of more complex languages from a simpler one. Pumping lemma for context-free languages. The pumping lemma is a fundamental property used to prove that certain languages are not context-free. It states that for only context-free languages there exists a length p such that any string longer than p can be pumped. This lemma is an essential tool for understanding the limitations of CFLs. Applications of closure properties. Understanding closure property assists in designing compiler and traces for programming languages. They help in verifying the correctness of the language constructs and transformation. Additionally, closure properties are useful in automata theory and formal language processing. Limitation of context-free language. Context-free language can't express all patterns or structures found in natural or programming language. Their limitation becomes evident when dealing with nested or across referred structures. This motivates the exploration of more powerful language classes like context sensitive language relationship to other language classes. Context free languages are a proper subset of context sensitive language. They are also distinct from regular language, which have more closure properties. Understanding their relationship helps in classifying languages based on their complexities. Examples of context free language. Commonly, examples include arithmetic expression and programming language construction. The language of a balanced partnerness is a classic example of a CFL. Regular languages such as those defined by a simple pattern are also a context-free language. Context-free grammar construction. Constructing a context-free grammar involves refining production rules for generating strings. It is a crucial role demonstrating closure properties through grammar manipulation. Understanding grammar construction aids in language design and formal verification. Tools for working with CFLs. Various theoretical tools such as pushdown automata are used to study CFLs. Software tools can also analyze and manipulate context-free language. These tools are essential for practical application in programming language design. Conclusion on closure properties. Closure properties are fundamental to understanding the capabilities and limitations of context-free language. They provide critical insights into the computational power of grammars and automata. A true understanding of these properties is essential for advanced studies in formal languages. Further reading and references are given below. Thank you for watching the video. Please do like, share and subscribe.